Hello friends, once again welcome back to Triple tutorial channel. I am Lisha. In this video we will discuss about the major parts of power transformers and its functions. Already we have discussed the basic parts of transformer in detail, that is core and windings. In addition to these two basic parts, we need other requirements. They are listed here: core, winding, insulation, tank, terminals and bushings, transformer oil, oil conservators, breathers, radiators and fans, explosionment, tap changers, and finally Buchholz relay. So these are the major requirements or the major parts of a power transformer. So we can discuss about each parts in detail here. Okay. So let us discuss about the first part, that is transformer core. We know that function of transformer core is to provide necessary low reluctance path for the magnetic flux. In addition to this, core will provide necessary supports to the primary and secondary windings. Normally this core is made up with stack of thin sheets of high-grade grain oriented silicon steel. Silicon material is used here in order to reduce hysteresis losses. This core has mainly two parts, limb and yoke. These vertical portions are known as limb, and the function of the limb is to carry primary and secondary windings. These horizontal portions are known as yoke. This limb and yokes are magnetically coupled. So its function is to provide necessary low reluctance path for the flow of magnetic flux. And based on the construction of this core, transformers can be of core type transformer and shell type transformer. Already we have discussed about core type and shell type transformers in detail. If you want more details about this, you can check my previous videos. So next we can discuss about windings. Windings can be primary and secondary windings. Normally supply is provided to the primary side and loads are normally connected to the secondary side or the secondary winding. They are made up with conductors, normally of copper conductors are used, and they are insulated from each other to reduce eddy current losses. Okay, these points are very important for technical exams. Okay, based on the voltage ratings, this primary and secondary windings can be of high voltage and low voltage winding. If the voltage across the winding is higher than its current ratings, then we can say that it will be high voltage winding, and otherwise the windings will be low voltage windings. If the high voltage winding is provided at the primary side of the transformer, then automatically low voltage side will be there in the secondary side of the transformer, and such transformers can be step down transformer. If the high voltage side is provided on the secondary side and low voltage windings are provided at the primary side of the transformer, then such type of transformers are step up transformer, because high voltage is provided at the secondary. That means voltage is upping, that means which ups the voltage. Okay, here you can see a three-phase transformers with windings, And windings with insulation, you can see this light brown colored portions are the insulations provided on the windings. Here you can see this. These portions are the windings and these light colored portions are the insulations. So always windings along with insulations are also provided. Third point, that is insulation. It is the most important section for a transformer. Failure of insulation may lead to a dangerous situation. Finally, that may lead to the damage of that transformer. And insulations are needed to provide in between the windings and between the windings and the core, and they are needed in between all current carrying parts of the transformer. We know that windings are the major or the current carrying parts in a transformer. The insulation materials must possess high dielectric strength, must have good mechanical properties, and must have high temperature withstanding ability. Because due to the flow of high current through these windings, heat losses will be there. So that insulation must possess high temperature withstand ability based on Joule's law. Okay. Normally the synthetic materials, paper, cotton, etc. are mainly used as the insulation materials for transformers. Here you can see this dark brown colored portion will be the windings, and this light brown colored portions will be the insulations provided on the windings. You can see here. Fourth important part of transformer, that is transformer tank. Okay, main function of the transformer tank is to provide protection for transformer core and windings. We know that core and windings are the major requirement for a transformer. So transformer tank will carry, or they will provide protection to this transformer core and windings from the external environment, and they will carry, or they serve as the container for transformer oil. Okay, and they will provide necessary supports to the all other equipments required for transformer. Okay, normally these materials are also made up with steel. If we want to reduce the weight and stray losses, sometimes aluminium material can also be used as a transformer tank. Okay. Fifth important requirement, that is terminals and bushings. From this name it is clear that terminals are provided at the end of the transformer windings. In this diagram you can see that these windings are provided here. The end portions of these windings are directly connected to these terminals. Three phases, you can see this. So the end portion of the windings are directly connected to the terminals, and bushings are also provided along with these terminals. Normally these bushings are made up with porcelain materials, and we can say that these terminals and bushings act as a safe passage to connect these windings to the conductor, or we can say these terminals and bushings are the mediator between this winding and the transmission lines or conductors. So these portions will connect to these windings to the conductor. That is the main function of terminals and bushings. Or otherwise we can say that they are used for connecting the incoming and outgoing cables. So simply we can say like this. Sixth important point or requirement, that is transformer oil. It is one of the major requirement for oil immersed transformers. We know that the function of the transformer oil is to provide necessary insulation between the conducting parts, means provide necessary insulation between the windings, and they are used for cooling purpose. In addition to these two functions, by checking the dielectric properties of this transformer oil, we can detect the fault in this oil and the windings. Normally, mineral oil is used as the transformer oil. Here in this picture, you can see that this will be the transformer main tank, and here you can see windings and cores are placed inside this transformer tank, and oil is filled in this tank. Okay, always remember that first we must place core and windings to this main tank, and then only we will fill the transformer oil into the main tank. Next important requirement or part, that is conservator. Conservator is nothing but the topmost region of the transformer. Okay, already you may notice this portion. So they are normally placed on the top region of the transformer. We know that when load changes, that may lead to the expansion of transformer oil in the main tank. The expansion means they may expand or contract due to the change in load. When load changes, that may lead to change the pressure and temperature inside this transformer oil. That will lead to the expansion and contraction of this transformer oil. During that time, this conservator will maintain the level of oil in the main tank. Here you can see an oil level indicator portion. It is visible. If the level of the oil in the main tank reduces, oil will fill to this main tank from this conservator automatically. And if the oils expands, then the excess oil will directly enter to this conservator tank. So conservator will maintain the level of transformer oil in the main tank. That is the major function of this conservator. Okay, normally these conservators and main tanks are connected through a pipe. Okay. Breather. They are normally present in oil immersed transformers have a conservator. We know that when load variations occurs, that may lead to the expansion of transformer oil due to the change in temperature and pressure variations. During that time, due to the change in pressure variations or due to the change in pressure inside the transformer oil, air flow will take place into the transformer main tank through a part, that is breather. So breather will act as a path for the flow of air into the transformer tank and from the transformer tank to the environment. We know that in the environment some moisture will be present. So this moisture, the presence of this moisture will be very dangerous to the transformer oil. That may lead to heavier short circuit fault in the transformer main tank. So it is necessary to avoid or separate the moisture, the presence of moisture in the air into the transformer, so that a material, that is silica gel, is provided in this breather portion. So if the air is coming from the atmosphere, that will directly enter to this breather, and this breather will absorb the moisture contents present in the air, and after that the air will directly goes through the transformer main tank, so that breather will separate the presence of moisture that present in the air coming to the tank. Silica gel will provide this function, means silica gel will separate the moisture contents. Normally, the pure color of silica gel must be in blue. If it absorbs moisture after a long time, the color of this blue or pure silica gel become pink colored silica gel. At that time, we must understand that it is necessary to replace this silica gel. Now it is in pink color, so we must replace this silica gel with pure silica gel. Its color must be, normally it is blue. Okay, in this way we can identify the silica gels and the amount of moisture present in this breather section. Okay, next important part, that is a radiator and fans. Here in this diagram you can see these radiators and fans. They are placed on the outside region of the transformer or transformer main tank. Okay, they are normally placed or provided for oil-immersed transformers. We know that according to Joule's law, heat will be dissipated in the transformer oil due to the flow of current through the windings. So due to the flow of current through the windings, heat will be generated, and that heat will be directly dissipated to the transformer oil, and that transformer oil is cooled by this radiators and fans. That is the main function of this radiator and fans, which is provided on the transformer main tank. Okay, next important part, that is explosion vent. Here in this diagram you can see that this will be the conservator, and these portions are the explosion vent portion. Normally this explosion vent is provided on the top portion of the conservator. Okay, so they will act as the emergency exit for the transformer oil and the air gases present inside the transformer. Okay, so the explosion vent will act as an emergency exit for the oil and the air gases present in the transformer tank. It is a metallic pipe with diaphragm at its end. You can see that these portions are the diaphragm, normally known as the diaphragm. When the fault occurs on the transformer tank, that may lead to the formation of some gases. If the fault is very severe, then the formation of the gases will also be very severe, and the pressure will changes. This excess of gas and the force will generate due to the change in this pressure. The formation of this force will be mainly based on the fault. If the fault is very severe, then the pressure changes will be very high in the transformer oil, and at that time that formed gases and the transformer oil will sometimes flows to the environment through this explosion went, then we can understood that some severe fault occurred in the transformer main tank. So explosion vent will helps to identify some fault is very severe in the transformer. So we can check that fault. Okay. Next important requirement, that is tap changes. Tap changes are mainly used to adjust the secondary voltage of transformers, not primary. Tap changes are used to adjust the secondary voltage of transformers. We can change the secondary voltage of transformers by adjusting the turns ratio of the transformer. Okay. Normally these transformers can be of two types, on-load tap changes and off-load tap changes. We can provide tap changings on the transformer at the load conditions, then it is known as on-load tap changes. Off-load tap changes are normally operated under off-load conditions. Okay, these are the main two tap changes. We can control or change the tappings either manually. Normally it is provided manually. Okay. The last important requirement, that is Buchholz relay or Buchholz relay. It is the most important part of an oil immersed transformer, rated over 500 kilovolt ampere. It is a gas actuated relay. It can be used to detect the fault occurs in the transformer main tank. Okay. When any fault occurs in the transformer oil, that will lead to the formation of some gases like hydrogen, carbon monoxide and methane, etc. And these gases will be present on the top of the transformer oil. This will slightly move towards the conservator tank through a connecting pipe. Already we have seen that conservator is connected to the main tank through a pipe. When any severe fault or any fault occurs in the transformer main tank, that will lead to the formation of these gases, and these gases will also flow through this pipe to the conservator, and between this main tank and the conservator, Buchholz relays are provided. So this formed gases will slightly move towards this Buchholz relay, and there will be a mercury sensor will be there, and based on the range of this fault, that means if the fault is not severe, then this mercury gases will activate the trip circuit, some alarm circuits. Then we can identify that some fault is occurred in the transformer main tank. If the fault is very severe, then mercury will senses to trip the circuit, and finally circuit breakers will open and primary and secondary windings will interrupt the current flow. In this way, this Buchholz relay will detect and protect the transformer. The Buchholz relays are mainly used in transformers to protect the transformer by detecting the fault. It is placed in between the conservator and the main tank. So these are the major parts of transformers. Here you can see the images of Buchholz relay. You can see a separate Buchholz relay circuit relay here. Okay. Here you can see the position of this Buchholz relay in a transformer. This will be the conservator, and this will be the main tank. And Buchholz relays are placed in between this conservator and the main tank. It is placed outside this main tank, but there will be a connection with the main tank. Okay. So hope you understood this video, and thank you.